Dr. David Diamond is a neuroscience professor challenging conventional views on cholesterol and cardiovascular health through his research and lectures. Please welcome Dr. David Diamond.
Thank you, Dave, not only for inviting me to speak, but for the outstanding work that you've done. So today, my goal is to address that LDL elephant in the room that's been haunting this meeting. And a secondary goal is to alleviate your concerns over high LDL when you're on a low-carb diet or for the LMHRs. So I'll share my story. It's also my disclosure. It seems like everyone has a story to share. Here I was 46 years ago when I began my neuroscience career, recording brain activity in rats. And in the past 4 decades, I've studied PTSD and Alzheimer's disease. I've been a VA career scientist, and I've received funding from all these federal organizations. But I'm not going to talk about my neuroscience research today. What I'm going to talk about is more personal and entirely unfunded. So this is one of my blood tests. 25 years ago, I was diagnosed as being extremely high risk for developing heart disease. Here you could see my triglycerides at 771 and my HDL down in the low 30s. My ratio was more than 10 times what is considered healthy. And there were blood tests in which my triglycerides were as high as 1,000. So, wow, that's what my doctor said. And you could see some of the notes that were on my charts about how concerned my doctor was. He urged me to go on a variety of medication. He have recommended meds to patient. Is he amenable? And I was not. I decided to learn about the biochemistry of triglycerides and HDL and realized that the reason why I had such high triglycerides was because of my high carb diet. So I cut back on the carbs, which helped me to not only lose weight, but I also reduced my triglycerides by about 75% or more and raised my HDL by about 25%. So once my triglycerides got into a range in which I could then measure my LDL, it turned out to be sky high. So now I had a second problem, which is in common with the LMHRs, in which I felt really healthy, but my doctor again is urging me to go on medication, including statins. So this is the problem, and this is the challenge in which we're faced with, which is high LDL appears to dramatically increase your risk of developing heart disease, even if you're an LMHR or you're overall healthy. So Dr. Budoff compared the LMHRs to the FH people, so it's in a sense it's a comparator group, and what you have are, he compared it to people with FH. And these are people who have abnormality in their lipid processing, their LDL receptor. And so from birth, they have extremely high LDL. And as it says right there, there's a known risk for cardiovascular disease. So if you look then at the literature, you find a consensus, which is that for people who have FH, you see that if that LDL is not reduced, they're at very high risk of developing cardiovascular disease and die prematurely. So you can expect them to be dying of cardiovascular disease and overall all-cause mortality in their 30s, 40s, and 50s. So as a scientist, I just looked into the literature and asked the question. So based on their high LDL, these people should have premature cardiovascular disease, all-cause mortality, not only in people with FH, but in non-FH people who have extremely high LDL. So this study is representative of numerous studies on people with FH. And so this is a beautiful study in which you're looking at the rate of death for people at different ages relative to the general population. So 1.0 is the rate of death in the general population. So in the first few decades of life, people with FH do show all-cause mortality, do have a higher rate of death, But it's only a small percentage of the FH people. And that is why, even though it's somewhat above 1.0, it's not statistically significant, which means that most FH people are not dying in the first 4 decades of life. Curious thing happens after the age of 40. The rate of death of people with FH is actually declining. So you see how it's going lower. Again, this is the age-specific mortality for the general population, and in fact, it's statistically significant for the people in their 70s, who are dying at about a 40% lower rate than the general population. And this is actually consistent with the literature. So let's look at what's actually causing these people to die. And so we look specifically at the 70-year-olds. Why is it they have a lower rate of death compared to the general population? If we look at cause-specific mortality, what we find is that they have a normal rate. This is not different from 1.0. So they have a normal rate of cardiovascular death. They have a significantly lower, 50% lower rate of death from cancer, and about a 70% lower rate of death from other diseases. So it's important to realize, you may not have heard this ever anywhere before, but people with FH are healthier than the general population. This really would surprise anyone in a medical school or a cardiologist. It would be very surprising. But this has been consistently found, that people with extremely high cholesterol actually have great longevity. Now, it's not just the FH population. So I've worked with some outstanding clinician scientists, and we reviewed the literature on people with very high LDL looking at mortality. And there was not a single study that showed a higher rate of mortality in people with high LDL compared to people with low LDL, which is why we concluded this should certainly address the cholesterol hypothesis, that the LDL is seeping into our arteries and therefore choking off the arteries and causing premature death. So why is it that elderly people with high LDL are so healthy? And this has been raised in a discussion already at the meeting, that LDL is a part of our immune system. And so you have up here, you have these damn buttons. You have up here, LDL is a part of immune system. And this is the study that Dave was referring to earlier, that animals that have extremely high LDL will survive a bacterial attack far better than animals with very low LDL. And specifically, it's the endogenous LDL that protects against the lethal effects of infection. And that is what makes people with high LDL so healthy. And one way to see how healthy people are with the high LDL, and this is of all ages, is in this study. So you have 30,000 people followed for 10 years, and a subset of those people develop sepsis. And this is an extreme immune reaction to an infection in which the immune system targets the organs and can cause severe organ damage and cause mortality. And what you have is the people with the lowest LDL were much more likely not only to develop sepsis, but also more extreme organ damage. And this effect occurs in people who have naturally low LDL, as well as the people who are taking statins to lower their LDL. So it's independently associated with people taking statins, as well as people with naturally low LDL. And the authors interpreted this based on the literature that says how important LDL is to clear bacterial toxins. So people with very low LDL have a less efficient immune system for targeting infection as well as cancer. So while your immunologist would be very happy to hear that you have high LDL, your cardiologist is still going to be very concerned. So let's talk about high LDL, especially with people with FH, and heart disease. So here you have a study in which you have people with FH, and they're all on statins. And after years, after 10 years, a subset of those people have developed heart disease, and a subset are free of heart disease. So what you see here at the top, in red, they have no heart disease, and in blue, a subset of them have heart disease. And you look at their LDL levels, and there's no difference between those with heart disease and those without heart disease. What was different between the two, and which has been talked about, is the best indicator of whether or not someone will develop a coronary event, and that's coronary artery calcium. So the people that developed the heart disease had extremely high coronary calcium, and those without had zero calcium. What is also relevant is their blood sugar. So those with heart disease had significantly higher fasting blood sugar in the prediabetes level, and those that didn't have heart disease had nice low blood sugar. So these are two incredibly important measures that just blow away LDL. So it's not the LDL, they're metabolic factors that are far more important than the LDL. A few years ago, we reviewed the FH literature, and we could relate then the subset of people that developed heart disease with FH had insulin resistance. So here is a really nice paper looking at coronary artery disease in people with FH compared to the general population right here, which rate would be 1.0. Those with FH that had low fasting insulin and were not overweight right here, and you see no significant difference in their rate of coronary artery disease. It's not until you get to people that have high fasting insulin and a combination high fasting insulin and they were obese that you see a dramatic increase in coronary artery disease. So these two factors are far more important because this takes into account that LDL was irrelevant. LDL did not predict coronary artery disease in these people. So let's look at another study on FH. Here you have people not on statins, in which you're looking at the level of LDL that they would have had for their entire life. And so it's quite similar to the LMHR. Their total cholesterol is over 350. Their LDL is about 275. And you've got one group with coronary heart disease and one group without coronary heart disease. And you see that these levels are equivalent. The ones with heart disease have slightly lower HDL and higher triglycerides. But what really matters is there's an additional genetic anomaly that can occur in people with FH. And so these people have what's called a polymorphism in a gene that produces prothrombin. This is a clotting factor. And this is not only in people with FH, this is universal across the population. People who have this particular polymorphism for this protein, the prothrombin, they have a higher rate of heart disease because it triggers more clotting. But the most important component of this is it's all independent of the LDL. This is an independent factor that increases risk of heart disease in the people with FH. So there's a vast literature looking at excess clotting as well as reduced ability to break up clotting or fibrinolysis. And I've been able to work with an outstanding group of individuals, and we review the FH literature. And what we found is that when clotting factors are measured, you see that they're far superior to LTL in being able to be associated to heart disease. And so here's our conclusion, in which in those individuals with FH who suffered from premature cardiovascular disease, the clear factor which was far superior to LDL, was coagulopathy. That is, they had increased clotting factors such as fibrinogen and reduced ability to block clotting, such as fibrinolysis. So these are factors that are typically ignored, and people focus on the high LDL in familial hypercholesterolemia, but there are these other factors that are far more important in indicating who is it that develops cardiovascular disease. Now, is LDL completely innocent of causing heart disease? Well, it gets complicated. So what we need to do then is look at the LDL particles, which are sensitive to our metabolism. So when we are healthy with low triglycerides, high HDL, low blood sugar, what we produce is called this large buoyant LDL particle. For a person that has high triglycerides, high blood sugar, low HDL, then you produce what's called small dense LDL. I call it all small damaged LDL. And that's down here at the end. And that's really important because the small, dense LDL is found in people who are metabolically unhealthy. So let's look at a study that addressed this. So you look at the people that have very high, small, dense LDL, and that's in red, and you look at their events as well as their metabolism. So the people that have high, small, dense LDL have very high triglycerides. Those who have very low, small, dense LDL have low triglycerides. And the people who are diagnosed with metabolic syndrome, you have about 75% of them have very high, small, dense LDL, and those with low, small, dense are very unlikely then to be diagnosed with metabolic syndrome. So small, dense LDL is a component of a damaged metabolism. So in these people, now let's look at events. So the people that developed heart disease, this is a follow-up over a decade. The people that have the highest small, dense LDL also have the most coronary events. The people that had very low, small, dense LDL had a much lower coronary events. When we look at the large, buoyant LDL, which again is found in people with low triglycerides, high HDL, you see no association of this form of LDL with coronary events. So it's really important to understand LDL exists in the combination, all the factors of the metabolism, and it is affected, therefore, by the metabolism. But in the healthy person with ideal metabolism, you see dominance of large, buoyant LDL. Also, it's important to see that LDL-C is just a hybrid measure. LDL-C is a combination of the small, dense, and the large, buoyant LDL. So when we go on a low-carb diet, what happens is that small, dense LDL shrinks, there is less of it, and you have an increase in large, buoyant LDL, which may increase overall LDL-C. So you see how poor the LDL-C measure is because it's taking into account both the small, dense, and the large LDL. And that large LDL can get really high when someone goes low carb, which inflates the LDL-C. Let's look even further. What also contaminates LDL-C is a structure that's very similar to LDL, but functionally is quite different, called Lp(a), which is involved in the breakdown of clots. High Lp(a) can reduce the ability to be able to break down clots. So Lp(a) is included in that standard lab LDL-C measure. So what's important about this study is that these investigators were able to separate the Lp(a) component from the total LDL-C. And what they concluded was when you separate the Lp(a), which is associated with heart disease, LDL-C is no longer associated with heart disease. So you see how contaminated the LDL-C measure can be. So are there observational studies? Can we actually say something about the lean mass hyperresponders from observational studies? So here is a study in which you're looking at ischemic heart disease in people. This is not in FH, this is a general population. And you look at people that have an ideal kind of ratio, triglycerides, HDL, and that's in blue. So that ratio is less than 1.7. Or you have people that have a poor ratio, in which the triglyceride to HDL ratio is over 3.1. And now you're actually looking at the incidence of heart disease. And you find it's extremely rare for those people with a very good ratio and much higher incidence of heart disease in people with this poor ratio, triglycerides to HDL. And this is for people who have an LDL that is less than 170. Now let's look at the people who have higher LDL-C. And it's exactly the same. The people with the ideal ratio have a low incidence of heart disease. The people with a poor ratio have a high incidence of heart disease, and it's completely independent of their LDL levels. The authors then concluded that people that have hypercholesterolemia with low triglycerides and high HDL, that there really isn't a reason for these people to be medicated. Now, this paper is from 2001, but it really kind of precedes the LMHR observation because these people are quite a bit like LMHRs. And it shows that that higher LDL tells you nothing about the incidence of heart disease in these people. What about interventional studies? Are there studies that can tell us about LMHRs right now, if they would benefit with the use of a statin? So here's a paper that was actually discussed this morning, the 4S study, which is one of the largest effects ever as far as statin benefits. But the nice thing about this study is it's a reanalysis of that 4S based on people's triglyceride to HDL level. So in this reanalysis, everyone in the study had high LDL-C in the range that you can see from 176 to 195. Again, you're in the LMHR range. So what you've got are two groups. One group has very high triglycerides at 195 and low HDL, so their ratio is 5.9. These people are unhealthy. They have what's called atherogenic dyslipidemia. And you're comparing them now, again, to the people with extremely high LDL, but they've got low triglycerides at 89, high HDL at 63, so their ratio is 1.4. And they're called isolated high LDL. They're LMHR-like. And so now what you've got are four groups. You'll have placebo groups, and you'll have the healthy and the unhealthy, all of which start off with high LDL. So what we have here is the placebo group is showing a high incidence of coronary event, and their LDL is 185. They are given a statin, which reduced their LDL and dramatically reduced the incidence of events. This is the biggest effect I've ever seen with a benefit with statins reducing from 35 to 20%. That's an absolute risk reduction of 15%. But now let's look at the people with the same high LDL, but these are healthy people. So these people now have that same high LDL at 182, but these people have low triglycerides and high HDL. And so you see that dramatic reduction in the incidence of heart disease, which is independent of their LDL levels. And now these people are given a statin, and that is a non-significant effect. There is a dramatic reduction of LDL down to about 112, but no significant benefit when these people are given a statin. So in a sense, you have a choice. So if you have high LDL and also high triglycerides, low HDL, which means you're metabolically unhealthy, you can take a statin, and this would indicate there would be benefits. But along with those benefits come the side effects, which I completely agree with Dr. Ali, that there would be cognitive side effects, increased incidence of diabetes, as well as muscle issues. Or you could lower those triglycerides, raise your HDL with lifestyle dietary changes. There is another study that relates to this as well. And this was done in elderly people that had high LDL. And so you had people who either had high LDL and low HDL, or high LDL and high HDL. So what you've got here, once again, is the people with low HDL, okay, given the statin, pravastatin, had a lower incidence of coronary events. So there is a benefit in taking the statin to the people who are unwell, that is metabolically damaged. Now let's look at the people who have high HDL. So again, the placebo group shows a significant reduction in events because these are metabolically more healthy. And the placebo group, now we compare them to those given the statin, and there is no benefit. So this is a very clear indication that a statin can have a benefit for a person that is metabolically challenged. The statin does not have a benefit for someone who is metabolically healthy. And in fact, the authors point this out, that LDL baseline had no relation to the coronary event, and the reduction in LDL was also not related to any benefit. It all had to do with the initial HDL level. Those with low HDL had a benefit from the statins. Those with high HDL had no benefit from the statins. And so why is it that statins actually can benefit the people who are unwell? Well, it's been known for decades that statins have what's called pleiotropic effects. Statins have anti-clotting effects, anti-inflammatory effects. And so for the person that is unwell, that has excess clotting and excess inflammation, there can be a benefit of the statin. And it may very well be, I think we don't really know, but those small, dense LDL, we can call, is damaged. It's been oxidized. It doesn't bind well to the LDL receptor. It's got to be removed by macrophages. It is glycated, which means extra glucose is binding to that LDL and damaging its function. So potentially then, the statin is reducing all LDL, which means it's also reducing the small, dense LDL, which may have a role ultimately in developing heart disease. So ultimately, the statin benefit has really nothing to do with its LDL lowering. What's most important really are these pleiotropic effects. But again, what comes along with the statins are the well-described but largely ignored adverse effects. So summarize this for now. People with extremely high LDL, whether it's FH or not FH, can live a long, healthy, cardiovascular disease-free life. People with insulin resistance, metabolic syndrome, have the highest rate of cardiovascular disease, and that cardiovascular disease is independent of their LDL-C. The people with high triglycerides, low HDL, have a high rate of coronary events, and that is then associated with the small, dense LDL and is not associated with large, buoyant LDL. So statins can reduce coronary events for those that are unwell. Those have metabolic syndrome, and that is independent of their LDL-C reduction. And so then, what we also found with these intervention studies is that statins do not provide a benefit for people with isolated high LDL-C, which is like the LMHR. Isolated high LDL-C in people who are otherwise healthy. This would predict, therefore, that the statin should provide no benefit for the LMHR people. So is there a model then that can incorporate all of this to be able to understand cardiovascular disease and LMHRs? Well, the basic model is right here. You'll see this in textbooks and in reviews, that LDL somehow just finds its way through the endothelium. It's then oxidized, taken up by macrophages, and wreaks havoc, and then produces a plaque. Well, there's clearly something wrong with this, because it's well described that, again, as I've shown you, people with high LDL don't develop heart disease. So it can't just be a concentration-dependent effect of LDL simply pushing its way into the artery. If they did, then everybody with high LDL would have heart disease. So there's got to be more to this story. The critical factor that is not addressed sufficiently, the one that really is the physical risk factor that ultimately either protects us or leaves us open to develop heart disease, is called the glycocalyx, the endothelial glycocalyx. So in the typical model, all you see is an endothelium. But really what's happening in our artery is we've got this protective layer, kind of looks like a furry layer, and it lines our arteries. And this is what you see in a healthy person. Red blood cells can pass through, platelets can pass through without showing aggregation, without producing clotting. So you have a large, buoyant LDL, low blood glucose, triglycerides, and blood pressure, and so there is no damage to the artery. We are protected by the glycocalyx. What happens when we have more small, dense LDL, triglycerides, glucose? Calcium then can accumulate because there is literally damage now because the endothelium has been denuded of the glycocalyx. You have that damage. In goes calcium. In goes small, dense LDL. In goes platelet aggregation. This is now damage which is repeated over and over the course of decades. And that helps us really to understand what is happening at the structural level that ultimately leads to why there can be an association of LDL with heart disease, as well as why there's calcium accumulation. And so there's a really nice study done on healthy people without heart disease, looking at the very first indication of what develops the heart disease, and that is damage to the glycocalyx, which is down here. And so these people can actually measure the glycocalyx damage in people, and it shows the best prediction of who is it that develops heart disease. And this is primary indication for heart disease. So damage to the glycocalyx precedes any other measure, far superior, of course, compared to LDL. So to summarize, I've covered quite a bit of information in a short period of time. Much of what I've covered is in this review that I had the pleasure to write with Ben Bickman and Paul Mason. We reviewed all the benefits of low-carb diet, and the only real concern is this increase in LDL-C, which I've already told you is a very poor measure of heart disease risk. So LDL-C is largely useless. People really shouldn't pay attention to LDL-C because it's a faulty marker. The low-carb diet improves all primary risk factors for cardiovascular disease. I would conclude then, there is simply no evidence-based reason for why LMHRs should even be concerned about their high LDL-C, and certainly why they should not be lowering their LDL-C. So I want to just acknowledge that there are just so many people that I've learned from. I've got chapters in these books, and I highly recommend the chapter on cardiovascular disease that was largely written by Dr. Ali. I was lucky enough to be included as a co-author. So I highly recommend this book on ketogenic diet. And I thank you.